Assalamualaikum and hello everyone. So in this video we're going to learn a new subtopic which is 1.2 mole concept, and in this specific video what we're going to learn is actually to define the terms empirical and molecular formula, as well as determine empirical and molecular formula from mass composition. Okay, so first is actually the definition itself lah. So what is actually empirical formula? It's a chemical formula that shows the simplest ratio of atom of the element present in molecule. So maknanya kata simple ratio lah. So contohnya apa ni? For example, if we have C4H6. So this is not an empirical formula. So kalau empirical formula dia kena simplest ratio. So dia boleh jadi C2H3. Same goes juga. Kalau C3H6, this is not an empirical formula. Sebab kita boleh simplifikan lagi. So dia adalah C1H2 ataupun CH2. Okay. And then the molecular formula is the chemical formula that shows the actual number of atom of each element in the molecule. So maknanya tadi kita kata this is actually what do you call this? This is empirical formula. So kalau yang ini kita boleh panggil dia sebagai molecular formula. Sebab dia menunjuklah berapa banyak yang ada. We're not going to simplify it. Okay. So that's actually a relationship lah. It could be related. The relationship between empirical and molecular formula is actually this one. Molecular formula is actually empirical formula, bracket, and kita ada subscript n, whereby n is a positive integer. Macam pelik apa benda ni. So n ni, how to find our n is actually molar mass divided by mass of empirical formula. Okay, so macam a bit jargon here. Apa ni? Apa benda semua ni? But it's okay. We're going to do some bits of calculation baru kita nampak. Okay, so first and foremost, to explain what we're going to learn is actually about the mass composition. So let's look here. Mass composition, example 1. A sample of hydrocarbon. So bila dikata hydrocarbon, H ni is our hydrogen lah. Hydrogen dengan carbon ni adalah our carbon lah. So that's why elemen kita ada CH. Okay. Okay, and then dia kata dekat sini contains 85.7% carbon and 14.3% hydrogen by mass, and its molar mass is 56 gram per mole. And then dia kata determine the empirical and molecular formula of the compound. Okay, so first and foremost sebenarnya kita kena cari empirical formula ni. Okay, dalam kes ni I have provided the boxes to you, but then for exam kamu macam mana, but then the value ni kamu sendirilah kena tahu. Okay, so first adalah elemen kita, what atom is actually present in the compound. So sebenarnya okay, kalau ada hint nak senang ingat juga sebenarnya adalah mamora. So sini is mora ni adalah number of moles, mole, and simplest ratio, mamora. So ni ratio lah, ra tu sebenarnya our ratio. Okay, so how does it work? Okay, so jom kita tengok. So first one is element. We have our carbon and hydrogen. Okay, so that is the element itself. So mass is actually mass grade in gram. So sekarang ni dia bagi in percentage je. So bila kita tambah ni 85.7% ni dengan 14.3% ni, bila kita tambahkan we get 100%. Okay, so maksud dia these two kalau kita tambahkan equal to 100%. So 100% kita boleh assume dia sebagai 100 gram. So apa yang kita akan tulis first and foremost, kita akan tulis assume mass is equal to 100 gram. Okay, so sekarang ni barulah kita boleh assume yang 85.7% ni akan jadi 85.7 gram. Here is 14.3 gram. Okay, so dekat sini because I have put the symbol ataupun the unit here, so tak perlulah miss tulis unit dekat sini. So dekat sini I'm just gonna include the data. So maknanya dekat sini 85.7, here is 14.3. Okay, so that's it for the mass. Okay, how about number of moles? Okay, so sebenarnya if you still remember from SPM ataupun waktu kamu PDT dulu, number of mole is actually mass divided by molar mass. Okay, mass tu kita dapat pada mana? It's from the box itself. But how do we get molar mass? Ataupun bahasa Melayu jisim molar. Okay, so again, it's kamu tak perlu hafal, it's actually in your list of constant. So tadi kita nak carbon dengan hydrogen kan? Okay, so kita tengok. Kalau carbon, mana carbon? Okay, here carbon. Okay, jangan lupa we're gonna look at the right hand side here, yang paling hujung sekali. So carbon dekat sini is actually dia punya molar mass dia adalah 12. Okay, so kalau hydrogen mass dia adalah 1. So kalau tak hafal pun tak apa, no worries. You can see, you can look at yourself at your list of constant. So mana tadi? Ni. Okay, so how we gonna find it? So tadi kita kata carbon ni 85.7 divide by 12. So the value that we get is actually, again, what I would like you to do is actually, selagi dia tak final answer, we're going to take 4 decimal places. Okay, 7.1417. Okay, so tapi kalau case ni, hydrogen ni dah divide by 1. Macam mana nak 3 decimal, macam mana nak dapat 4 decimal places? Tak apalah, kita ambil je 14.3. Okay, so this is actually, okay, again, kenapa Miss tak tulis unit? It's up to you nak tulis unit dekat sini ataupun di sini, because I have put the unit here at the box on at your left hand side. So tak perlulah, there's no need for you to write it down again here. Okay, last one adalah simplest ratio of formula. Okay, so simplest ratio of formula maknanya kita tengok berdasarkan these two values, which one is the smallest one. Okay, the smallest one tu yang kita akan ambil, we're gonna divide by the smallest number between these two lah. So for example, if you have 3 boxes, so tengok between these 3 boxes, which one has the smallest value. So in this case, the smallest value is this one. So what I'm gonna do is that, okay, so kita dapat 7.147 divide by, okay, 7.1417. So we get here 1. Okay, how about H? H ni value dia adalah 14.3. So kita dividekan lagi again with our smallest number, which is 7.1417. Remember, between these two yang mana paling kecil? So the value will be 2. Okay, so how about our empirical formula? So sekarang ni kita tahu dalam ratio dia, carbon only has 1, hydrogen got 2. So dia akan jadi, jawapan dia akan jadi up to you nak buat C1 H2 ataupun CH2 sahaja, it's fine. So from these boxes you will get your empirical formula from the Mamora. But that is actually your empirical formula. The question want you to find the empirical and molecular formula. So sekarang ni kita tahu kita punya empirical is CH2. So how you gonna find your molecular formula? So dekat sini. And then we know that the relationship between empirical formula times N ataupun subscript N is equal to molecular formula. Okay, so how you gonna find N? N is actually molar mass divided by mass of empirical formula. Okay, so kat sini N kita dia is equal to molar mass. Kat tepi ni molar mass divided by mass of empirical. So molar mass dia bagi kat sini 56 gram per mole. So 56 gram per mole here divide by mass of empirical formula. So mass of empirical formula kita tahu adalah CH2. So carbon tadi kita tahu dia punya molar mass is 12. So here 12 plus dengan hydrogen dia, you got 2. Okay, so empirical dia punya molar mass dia H ni is 1, tapi sebab there's 2 of our hydrogen to sini. So when you calculate it, you get your N is equal to 4. Okay, so sekarang dapat N equal to 4. So kita dapat kat sini kan, N is equal to 4. So what is actually the molecular formula? Okay, so I'm just gonna write it down dekat sini. So kita tahu our empirical formula is CH2. Okay, tapi molecular formula kita is actually, okay, kita tengok kat sini. Molecular formula is equal to empirical formula, and in bracket it's N. Okay, so dekat sini CH2N. Tapi N kita dah tahu kan, N is equal to 4. So kita tahulah, maka the molecular formula is C4H8. Okay, so that's it for question number 1. Pun nak 10 minit dah. So for question number 2, you should try it yourself. Okay, but then untuk molar mass, jangan risau, kita boleh tengok berdasarkan our list of constant. Okay. So now let's look for example number 3. Okay, example number 3 ni lain sikit. So previously, if you have done your example 1 dengan 2, you got a whole value, dapat 1 dengan 2. Okay, but then when we look here, dia kata dekat sini, you must never run out values close to a whole number in order to get a simple ratio, but multiply the value by a factor until you get a whole number. So for example, if you got 0.25 times 4, kalau 0.33 times 3, 0.5 times 2, 0.75 times 4. So contohnya, kalau kamu dapat, again, what does it mean here? Kalau if you get 2.25, jangan kamu round off kan jadi 2. 3 pun tak boleh. So we must multiply it by 4. Okay. However, if the value is very close to the whole number, then it is allowed to round off the value. So sekejap. Okay, so let's look here on example number 3. So dia kata dekat sini, a sample of unknown compound was analysed and found to contain 4.2 gram of nitrogen, 12 gram of oxygen. So dekat sini Miss tahu apa yang ada dalam what is the element present is actually our nitrogen and oxygen. Okay, so next, what is the mass? Mass tu 4.2 for nitrogen, oxygen 60. Okay, so sekarang ni how to get the number of mole? Remember, dia adalah mass divided by molar mass. Mass dia 4.2 divided by molar mass. Molar mass of nitrogen. Mana nitrogen? Nitrogen. Remember, tengok the at your right hand side here. So it's 14. 14. So the answer we get 0.3. Okay, again. Unit tu, I haven't written it down here sebab ada dekat sini. Okay, and then the oxygen. Oxygen is 16 divided by, it's actually 12. It's actually 12 here, 12 here. Oxygen, list of constant kita, oxygen, here it's 16. So, kat sini, the answer here is 16. So we got here 0.75. Okay. So now, sekarang ni, we got our moles. So for the simplest ratio of mole, we're going to divide by the smallest number. So between these two, which one is our smallest number is 0.3. So kita bahagikan 0.3 divided by 0.3 is equal to 1. 0.75 divided by 0.3 is equal to 2.5. Okay, so how we going to run it off? Kita tak boleh, remember, kat sini kata if 0, ada certain value ni, unless lah the value is very near, 0.01. So for example, contohnya dekat sini nanti, you get sini 8.06. Yang ini bolehlah kamu run off kan jadi 8. Nampak tak dia macam dekat, close to 8. So boleh. Kalau 2.9, kita boleh run off kan jadi 3. Tapi dekat sini, it's 2.5. Jadi 2 boleh, jadi 3 pun boleh. So what we're going to do here, even though only one of the value yang we must multiply, we have to multiply both sides barulah equal. So here 2.5, 0.5 kat sini, timeskan dengan 2. So kat sini pun, here times 2, here pun must times with 2. So dekat sini dapat 2. Kat sini we got 5. So the answer would be final answer empirical formula N2O5. Okay, so that's it for example 3. So example 4 and 5, you could try it yourself.